Okay, point. I beg, na there. Hello? No, I drop my WhatsApp number now.
Bro, just mute your mic. No one wants to hear your voice.
What can I say? You don't hear my voice. Who is the speaking, sir? Who is that guy that just talk now? Now talk now. Listen. I don't tell you. I mean, I mute my mic. I'm not in the same class.
Reason so why did you
Class.
for class?
So you can't open you and fast. So equal here. Nobody is 200 level. Oh, you 100 level here.
Yeah, beg, just mute your mic.
I've been here before. Start me now. And this guys pay for this portal. So I hear that voice since. Now the guy just they make mouth. If you don't get anything, do go find work do now. Abba. You spend it
Just mute your mic. Shut up now. Shut the fuck up.
I should shut up. Just give me 2 reasons why I should shut up. Just 2 reasons why I should shut up.
Calm down. I beg, just shut up, my bro. Shut up, man.
I laugh my mind. I never talk.
Why not this so loud?
Yìí kan pariwo sí ọ̀n létí. Àwọn student wọ́n kàn pariwo sí ọ̀n létí.
Ṣé ti sáré jí fa láàdì ní báyìí? Tẹ fi láàdì báyìí. Ẹ já gbọ́ràn náà.
I don't know what to just keep quiet. Let people that want to talk. It's not
Tell him the money is much.
Hello. Yeah, ignore me, Abi. No verse. I make Baba no verse.
Hello, good morning, student.
Good morning, sir.
Yeah, how are you?
Good morning, sir.
Yeah, how are you?
Fine, sir.
So, we will start when it is. Yeah, we will start when it is.
Morning, sir.
8. What?
Okay, sir.
Yeah, I put a link on the chat box.
Okay, sir.
You can copy that link to your Telegram group so that other people can join. On the chat box. That's a YouTube link.
Okay, sir.
You can copy it to your Telegram group or send it to your people so that they can join via Telegram, YouTube.
Okay, sir.
Yes, I've sent the link, YouTube link to your chat box now. Did you see it?
Yes, sir.
Yes, sir.
Yeah, please copy it and send it to your people.
Yes, sir. We've seen it.
Yes, sir. Please copy it and send it to your people.
Yes, sir. We've seen it. You've seen it, sir.
Okay. I will also send it to the LMS page. People can enter there and join. I will also send it to the LMS page. People can enter there. Join. I will also send it to the LMS. anybody. Yes, sir. Morning on the level class, no? 100 level, yes. Like, morning on the level class. Yes, sir.
I better make everyone off their mics, please. Give me, I don't like and I better make everyone off their mics, please.
Don't worry. I will do that from here. About the document.
I don't just
Hello,
know
have
why.
you sent the YouTube link to your Telegram group?
Yes, sir.
Yes, sir.
All right, thank you.
Yes, I have sent it.
Hello, have you sent the YouTube link to your Telegram group?
Yes, sir.
All right, thank you.
Yes, I have sent it.
Yes. this thing is really serious.
Mommy.
Wow.
Esther, please off your mic, I beg. Off your mic, Esther, I beg. Let me talk to Esther. Esther, please off your mic, I beg. Off your mic, Esther, I beg. Let me talk to Esther. Esther, please off your mic, I beg. Off your mic, Esther, I beg. Let me talk to Esther.
Oh, don't talk actually. How about it? There's something like that. Hello, students. Yeah, I want to make at least two of you a co-host. Yeah, I want to make at least two of you a co-host.
Okay.
Yeah, I want to make what is this reading of?
Okay, sir. Yes, sir.
Okay. Why is this thing real cool like this? No, I get. I think this thing is real cool. I don't know.
Feedback. It's feedback, I think.
No, I get. I think this thing is real cool. I don't know.
Feedback. Feedback, I think.
No, I get. I think this thing is real cool. I don't know.
Feedback.
No, I get. I think this thing is real cool. I don't know.
I'm sorry for interrupting. But Akoni Toluwani and Akoni Toluwani and Akoni Mohammed. Please turn off the video.
So, Folarin Eniola, Folarin Enioluwa.
Yes, sir.
I've made you a co-host. Folarin Eniola, Folarin Enioluwa.
Yes, sir. Thank you, sir.
So you can mute people if they are disturbing the class.
Okay, sir. Thank you, sir.
You can mute people if they are disturbing the class.
There's an echo in you.
Obafemi Adegoke. Obafemi Adegoke. You are now a co-host. You can mute people when they are disturbing the class. You are now a co-host. You can mute people when they are disturbing the class. You are now a co-host. You can mute people when they are disturbing the class.
You guys should check off mic. Now you guys have sense. Pass this one. Now the echo with the year for this side. Mike, now you guys have sense. Pass this one. Now the echo with the year for this side. Mike, now you guys have sense. Pass this one. Now the echo with the year for this side.
Sounds good.
Mike, now you guys have sense. Pass this one. Now the echo with the year for this side. Mike, now you guys have sense. Pass this one. Now the echo with the year for this side. Mike, now you guys have sense. Pass this one.
Good morning, students. Yeah. First and foremost, I want to welcome you to University of Ibadan, Nigeria. Yeah. First and foremost, I want to welcome you to University of Ibadan, Nigeria. Adegoke, if you can enter the YouTube, please mute the mic there. I think it's the YouTube mic that is real. Adegoke, if you can enter the YouTube, please mute the mic there. I think it's the YouTube mic that is real. Adegoke, if you can enter the YouTube, please mute the mic there. I think it's the YouTube mic that is real. Adegoke. Share and control. This is oh, Jesus. Okay. So good morning, everyone. So I want to welcome you to University of Ibadan. And I believe you, good morning, everyone. You enjoy your orientation week. University of Ibadan. And I believe you, good morning, everyone. You enjoy your orientation week. University of Ibadan. And I believe you, good morning, everyone. You enjoy your orientation week. So, what is this now? Also, I want to welcome you to Physics 103 class, General Physics 3, titled the Behavior of Matter. Behavior of Matter. Also, I want to welcome you to Physics 103 class, General Physics 3, titled the Behavior of Matter. Behavior of Matter. So, I want to welcome you to Physics 103 class, General Physics 3, titled the Behavior of Matter. Behavior of Matter. So, I want to welcome you. Jesus. Okay, there are two of us. We take you this course. Dr. Oyeni from the physics department, and take you this course. And Ayala, who is talking to you now. Physics department. This course is a required course for many departments that I know, for many departments, but it is compulsory for many departments, and it is required first for some departments. But whether required or compulsory, I want you guys to be serious about it, because if you really listen well, you will be able to do well in the class. And the University of Ibadan, there's a particular attendance you must meet before you can sit for test or exam. So you must meet 70% attendance in class before you can sit for any of their tests or exam. So you must meet 70% attendance in class before you can see for any of their tests or exam. So I think we can start now. The something is real cool, but please let us just manage it like that. I will check what is happening later because the time is not on our side. So as I've told you before, and as I've said on the video uploaded, the title of the course is Behavior of Matter. But I want you guys to listen well. I want you guys to listen well. The title of the course is Behavior of Matter. Physics 103 in the previous year is Heat and Thermodynamics, Introductory Heat and Thermodynamics. But as from this section, it is called the Behavior of Matter. So that when you are registering, don't go and pick Introductory Heat and Thermodynamics. What you pick is Physics 103, Behavior of Matter. And I believe you get me clear. So let's start. So these are some recommended texts and materials you will need for this course. But most importantly, your lecture notes is highly recommended. Your lecture notes, your slides, or anything that your lecturer gives you is highly recommended. Don't leave your lecture note and be reading one textbook from anywhere. It's good you read textbook. It's very good you do your search, read textbook, search materials online, and read whatever. But give high priority to your lecture notes. Please, it is very, very important you take note of that. Okay. Course content: heat and temperatures, gas law, general gas equation, first law of thermodynamics, heat, work, and internal energy. Please don't send recording this thing again. Please stop it. I'm already recording. Don't send recording request again. I'm already recording. It's disturbing me. Please stop it. I'm already recording. So heat and temperature, gas law, first law of thermodynamics, thermodynamics processes, zeroth law of thermodynamics, kinetic theory of gas, and so on and so on. All this one is already on your page that I put last week. Please. And I believe you guys have downloaded the video and the lecture materials and you have gone through them for proper understanding. So I will explain everything I've put in the lecture note now and interact with you guys to know how far you have gone on the course. So in this course, Physics 103, Behavior of Matter, the following terms are vital. They are keys if you really want to understand this course and do well in it. We have temperature, we have heat, we have thermal contact, thermal equilibrium, zeroth law, temperature scales, thermometers, and thermodynamic processes. So let's start. Temperature and zeroth law. So first and foremost, what is heat? I believe we have done all this in secondary school. If you have gone to a good secondary school, which I believe most of us, went to a very good secondary school. So heat is the transfer of energy from one object to another object as a result of difference in their temperature. That is as well difference in temperature between the two objects. So if you consider the definition, I said as a result, that means before energy can be transferred from one object to another, there must be a particular condition that must be fulfilled. The condition is that there must be a difference in the temperature between the two objects. That's one of the conditions. So it's very, very important. If there's no difference in the temperature, it will not flow. So that's why I put here condition necessary for energy to flow between bodies. Number one condition, the two bodies must be in thermal contact. Yes, thermal contact must be established between the two bodies before they can exchange energy by it. The second condition is that despite being in thermal contact, they must not be in thermal equilibrium. That is, there must be a difference between the two temperatures. So take note. I said note, it always flows from a higher temperature body to a lower temperature body. So yes, we all know this, even right from SS1 or even GS3. Two objects are said to be in thermal contact with each other if energy can be exchanged. If energy can be exchanged between them. Yes. The first condition I put here is that the two bodies must be in thermal contact. Then what's the meaning of thermal contact? I said the two objects are said to be in thermal contact with each other if they can exchange energy between each other. So take note. Then third law of thermodynamics. This law states that if two objects A and B, which are not in thermal contact, are separately in thermal equilibrium with third object C, then object A and B are in thermal equilibrium with each other. What am I saying in essence? I say if I have three objects, A, B, and C, if I test object A with object C, and I said that two of them are in thermal equilibrium, and I test object B with object C again, and B and C also are in thermal equilibrium, then I can conclude that A and B are also in thermal equilibrium. So, for instance, if I have three boys, and I say the first one is a friend of the second one, though this may not be this may not be true. This may not be true generally, but in most cases it happens that you are a friend to this boy, and this boy is a friend to the third boy. Definitely, I can say the first boy and the third boy are also, or the first boy and the second boy are also friends. This law allows the development of thermometers. In this case, object C is our thermometer. That is the reference object. For example, the length of a mercury coulomb may be used as a measure to compare the temperature of the two other objects. Yes, if you have seen thermometer before, or you have been to the hospital before, when they put a thermometer on your armpit or anywhere on your body, you will see that something will be rising up. That's the length of the mercury coulomb in that thermometer. So it can be used to compare the temperature of the two other bodies. Then what's the meaning of thermal equilibrium we are saying? Thermal equilibrium is a situation in which two objects will not exchange energy by heat or electromagnetic radiation if they were in thermal contact. So that means it is possible for two objects to be in thermal contact and not exchange heat between each other. Yes. So it means the two objects are in thermal equilibrium. Because it can only flow if one has a high temperature and the other has a lower temperature. But now they are in thermal equilibrium, each cannot flip. In other words, this occurs when the two objects in thermal contact with each other cease to exchange the energy by the process of heat or by electromagnetic radiation. Yes. So this is another way to define thermal equilibrium. So thermometer and temperature scales. Thermometer and temperature scale. All these ones, they are elementary that I believe you know right from where you are in secondary school. So for instance, if a metal tray and a plastic bottle are brought out from the same freezer, you know, definitely the two objects will have the same temperature because you brought them from the same environment. But when you touch them, you will see that the two objects will feel differently. You will feel different temperature from the two objects because they have different thermal conductivities. The object with higher conductivity, that's the metal tray, will feel colder to touch than the one with lower conductivity. The object with higher conductivity, that's the metal tray, will feel colder. Inference. What can we draw from this? It means our senses is a qualitative indicator of temperature, but it is unreliable and could be misleading. Yeah, it could be misleading. So because of that, we need a device that can measure temperature called thermometers. Thermometers are devices used to measure the temperature of a body or of a system. So at least 98% of students in this class know this. 98% of students in this class know this. So temperature of an object depends on two things. Listen and listen carefully. Temperature of an object depends on two things. But one, it depends on measuring devices you use for the measurement and on the temperature scale you adopted. So if you measure the temperature, that temperature depends on these two things. The device for the measurement, or probably you are using a color as the indicator of temperature, or you are using resistance, or you are using volume at a constant pressure, or so it depends on that, and it still depends on the temperature scale adopted. So let's look at most common temperature scales. Number one, we have a thermodynamic scale, which is also known as Kelvin scale. We have Celsius scale, and we have a Fahrenheit scale. Though few scales have been used, there are many types of devices for measuring temperature. There are many types of devices for measuring the temperature. All thermometers are based on the principle that some physical properties change as temperature changes. You know, we know that when I increase the temperature of the body, something in that body will change physically. Probably I have a mercury now inside a container, and I increase temperature. I will see the length of that mercury increasing. That's what happened in clinical thermometer that I explained the other time. So that thing is called the thermometric properties of that thermometer. It's called the thermometric properties. So let's look at some physical properties that change with temperature. Number one, we have the volume or the length of a liquid. Example is that of the length of mercury that I said just now. Then the length of a solid also can increase when you increase the temperature, or when you decrease the temperature, the length can decrease. Then the pressure of a gas at a corner volume also can change as a result of temperature. You still have the volume of a gas at a constant pressure. Then the electric resistance of a conductor can also change where you change the temperature of the object. The color of an object is also another indicator to show that temperature has changed. And lastly, we have the EMF of a thermocouple. So let's look at the temperature scale one after the other. Though I've put all this one in the video and the lecture notes that I post on the LMS, because just to recap. So the first one that we are taking is the thermodynamic scale. What are the properties? What are the characteristics of this scale? On this scale, ice sponge has temperature of 273.15 Kelvin, and triple point of water is defined as 273.16 Kelvin. But what is triple point of water? We know the ice sponge, but what is triple point of water? Triple point of water is the temperature at which a saturated water vapor, pure water, and melting ice are in equilibrium. So the pure water is the distilled water from which the soft air has been driven out, from which the soft air has been evacuated. So take note of that. In other words, triple point of water can be said to be as the temperature at which liquid water, gaseous water, and solid water coexist in equilibrium. That is temperature at which these three states coexist together is what is called a triple point of water. So if you consider the previous slide, you will see that there's a little difference between the triple point of water and the ice sponge. You can see 273.15, that's ice sponge, while triple point of water is 273.16 Kelvin. So let's look at the causes of this difference. Let's look at the causes of this difference. Number one, pressure difference. There's a pressure difference between them. Ice sponge is at 760 millimeter mercury, while triple point is at 4.6 millimeter mercury. The second reason is that we have removed the soft air from distilled water used for the triple point. So these are the 2 points or 2 reasons why we have difference between triple point of water and the ice point of water. Then another property of Kelvin scale is that the steam point is at 373.15 Kelvin. The scale is divided into 100 equal degrees between the ice and the steam point, and this is known as a fundamental interval. That is the difference between this carefully. I said is the temperature at which the pressure of a gas is 0. So at lower temperature than absolute 0, the pressure becomes a negative. The pressure becomes a negative. So I will show you this graphically when we get there, so that we can have a more understanding. Then the second scale, let's pick a Celsius scale. The ice point of this temperature is at 0 degrees Celsius, while the steam point is at 100 degrees Celsius, both at the pressure of 760 millimeter mercury. That's 1 atmospheric pressure. The scale is also divided into 100 equal degrees between the ice point and steam point, which is also known as fundamental interval. The number of division on Celsius scale is the same as that of a Kelvin scale. So, and I believe we know this before. Relationship between Kelvin scale and Celsius scale. So what is the relationship between Celsius scale and Kelvin scale? That is, if I'm giving a temperature in Celsius scale, how do I want to convert to Kelvin scale? Or if I'm giving the temperature in Kelvin scale, how do I want to convert to Celsius scale? So I can use this equation 1. So if I'm giving this temperature TC, that's temperature in Celsius scale, and I want to convert it to Kelvin scale, I will need to add the 273.15 to it. Or if I'm giving temperature in Kelvin scale and I want to convert to Celsius scale, I will need to minus 273.15 from it to get the temperature in Celsius scale. So this is very elementary, I believe. So, but there's another opportunity for you to.
273.15 to it. Or if I'm giving temperature in Kelvin scale and I want to convert to Celsius scale, I will need to minus
273.15 from it to get the temperature in Celsius scale. So this is very elementary, I believe. So, but there's another opportunity for you to.
273.15 to it. Or if I'm giving temperature in Kelvin scale and I want to convert to Celsius scale, I will need to minus
273.15 from it to get the temperature in Celsius scale. Okay, so this is very elementary, I believe. Okay, so, but note, there's another opportunity for you. Take note of this. This point very well. The difference of two temperatures on Celsius scale is the same as the difference of their corresponding temperatures on Kelvin scale. That is, if I'm giving two temperatures, 1.15 from it to get the temperature, and I check they are different. That is, I subtract the first one. This is very elementary, I believe. I get a value. Note, if I convert, take note of this temperature to Kelvin scale. Before I Kelvin, this point very well scale now. The difference of the temperature on Celsius scale is the same difference of same value corresponding temperature, but for Kelvin scale. If I'm giving two temperatures, and this is the Celsius 5 using to get this temperature, and I check they are different. That is, I subtract the first one. This is very elementary, I believe. I get a value. Note, if I convert, take note of this temperature to Kelvin scale. Roman figure 1, this point very well. Temperature in Kelvin of the temperature on Celsius scale. That's the get the same value corresponding temperature, but for Kelvin scale. If I'm giving 1.5, and this is the Celsius 5 using to convert this temperature, and I check they are different. That is, I subtract the first. This is very elementary, I believe. Equation 2 is the second temperature difference on Celsius. Take note of this temperature to Kelvin scale. Roman figure 1. This one very well. Temperature on Celsius scale. That's the get the same value. When I subtract the Kelvin scale, if I'm giving 1.5, and this is the Celsius 5 from that to convert this temperature, and I check the difference. That I subtract the first. This is very elementary, I believe. Equation 2 is the second temperature difference. Take note of this temperature to Kelvin scale. This one very well. Temperature of two temperatures on Celsius scale. That's the when I subtract the if I'm giving 1.5, and this is the 5, and I check the difference. I subtract the this is very elementary. When I subtract the if I'm giving 1.5, and this is the 5, and I check the difference. I subtract the this is very elementary. 1.8 degrees. Unlike the previous of two temperatures on Celsius, when I subtract the if I'm giving 1.5, and this is unlike the and I check the difference. I subtract the this is very elementary. 1.8 degrees. I'm giving temperature in Celsius. When I subtract the difference, if I'm giving 1.5, and this is unlike the and I check the difference. I subtract the this is very elementary.
Yes,
Hello, sorry, students. So the technical team was serious. So I would like to end the class here. So the issue will be discussed before the next class. Please, but before then, please make sure you submit an assignment on your page. Hello, sorry, students. And the message technical team was serious and LMS. I would like to end the class here. Please make sure you check the page to discuss before the next class information. Please, but before then, I don't need to submit. Let's pick the next class and assignment on your page. Hello, sorry, I will also and the message technical team was serious and LMS. I would like to end the class here. Please make sure you check the page to discuss before the next class information. I don't need to submit. Let's pick the next class and assignment on your page. Hello, sorry, I will also and the message technical team was serious and LMS. I would like to end the class here. Please make sure you check the page to discuss before the next class information. I don't need to submit. Let's pick the next class and assignment on your page. Hello, sorry, I will also and the message technical team was serious. Hello, you can unmute yourself. I would like to unmute yourself now and stop. Make sure you check the page to discuss before the next class information. You can unmute yourself. Let's pick the next class and assignment on your page. Hello, sorry, I will also hello, you can unmute yourself and hello, you can unmute yourself. I would like to unmute yourself now and stop. You can unmute yourself. So I sent a message to your chat box. I said we end so before the next class, I will make sure you can unmute yourself and hello, you can unmute yourself. I would like to unmute yourself now in class. Hello. I sent a message to your laptop, you can use I said behind the machine. And also before the next class,